we want to determine the derivative of the given function. The first thing we should notice is we have a product of two functions. So if we call the first function f and the second function g, the product rule tells us the derivative of f times g is equal to f times g prime plus g times f prime. Or we can say the derivative is equal to the first function times the derivative of the second plus the second function times the derivative of the first. And there's one more thing we should notice here. In order to find the derivative of the square root of x, we want to rewrite this as a rational exponent. So let's rewrite this one more time. F of x is equal to 2x to the second minus 5 times 3x plus x to the 1/2 power. So we'll use this form to apply the product rule. So now that all the terms are in the correct form, we can apply the product rule. So the derivative is going to be equal to f, or our first function, times the derivative of g, which is our second function. The derivative of 3x is 3, plus the derivative of x to the 1/2 would be 1/2 x to the 1/2 minus 1, which will be negative 1/2, plus the second function, which is 3x plus x to the 1/2, times the derivative of the first function, which will just be 4x. Now that we have found the derivative, the rest is algebra. We have to multiply all of this out and then combine like terms. So we'll have four products here, 1, 2, 3, 4, and we'll have two products here when we distribute. So f prime of x is equal to, we'll have 6x squared, and then 2x squared times 1/2 x to the negative 1/2. Well, 2 times 1/2 is 1, and x squared times x to the negative 1/2, we add our exponents, we'll have x to the 3/2. So plus x to the 3/2, and then minus 15, and then we'll have minus 5/2 x to the negative 1/2, plus, here we'll have 12x squared, plus 4x to the 3/2 power. So we have two x squared terms. So f prime of x is going to be equal to, we'll have 18x squared. There are two x to the 3/2 terms, one here and one here. Remember, you can think of this as 1x to the 3/2. So we have plus 5x to the 3/2. This term has an x to the negative 1/2 power. So let's go ahead and rewrite this as minus 5 all over 2x to the positive 1/2. Remember, by moving this to the denominator, we change the sign of the exponent, and then we have minus 15. Now, the last step you might want to do is rewrite x to the 1/2 as the square root of x. So we have 18x squared plus 5x to the 3/2 minus 5 all over 2 square root x minus 15. And then we have our derivative function. I guess I should mention one more thing. X to the 3/2 could be written in radical form. X to the 3/2 would be equal to the square root of x to the third, which is equal to 3 factors of x. So there is a perfect square factor here, so it would simplify to x square root x. So we could rewrite x to the 3/2 as x square root x, and I believe some textbooks may do that, especially if the given function has a radical in it. I hope this example was helpful.